All right. Okay, yes, I'm Fred Harris. I'm with the Biological Survey, and I'll be talking about the work we're doing to monitor vegetation at the Chippewa Prairie patch-burn-graze project. It's work that I'm doing with my colleague Dustin Graham. Advance. Click. Next.
I'm working on it. It won't let me. Okay, let's see. There you go.
This is where the project is located. It's on a glacial river terrace along the Minnesota River Valley near the town of Appleton, Minnesota. Really, we're doing two different monitoring projects there. We're monitoring wetlands as well as upland prairie. And for the most of my talk, I'm going to be talking about the work we're doing in wetland vegetation. And I'll briefly mention the upland work at the end. Okay. Just a little bit of context of the different projects that I'm involved in. We're monitoring upland prairie at 3 different places using exclosures to try to isolate the grazing variable. That includes up at Caribou WMA and down at Hole in the Mountain, as well as at Chippewa. And then we also have several other projects where we're monitoring prairie wetlands with grazing at several other management units in Lac qui Parle County and in Big Stone County. That's in collaboration with the Fish and Wildlife Service. Okay. So here's Chippewa Prairie. It's a 1,500-acre area. It's half owned by the Nature Conservancy and half owned by the DNR. It's on Chippewa Prairie Preserve in Lac qui Parle WMA. There's one perimeter fence around the whole outside of the area, and it's divided into several different burn units, which are outlined in green on this slide. Cattle are released in late May. They have the whole season to graze out there. They can go wherever they want within the project area. Each burn unit is burned in a different year, and cattle tend to focus grazing on the burn unit of that year, of the freshest grass. So as you rotate the burn around in the project area, you end up rotating the grazing pressure, and also then rotating periods of rest. So the numbers in white are the burn years for these different units. In recent years, we've had 100 cow-calf pairs and 4 bulls out there, which is a fairly light stocking rate. It's about 15 acres per pair. Current managers out there are Joe Blastic with the Conservancy and Walt Gessler. Okay. And why are we doing patch burn grazing out here? There are a number of reasons, including there's an interest in trying to use cattle to help control some invasive species such as sweet clover, grass banking arrangements with local producers where in exchange for grazing on the site, they manage their pastures and improve the condition of their pasture. And then last but not least, altering structure for wildlife that prefers short grass areas. Next. Such as marble godwits, which since the grazing started in 2012, managers have observed more of them and upland sandpipers utilizing the site. Okay, next. And why should we be monitoring the vegetation? It's because a lot of the studies of grazing have been done in hotter, drier places like Kansas and Oklahoma. And Minnesota has different conditions. We have moisture soils. We have a lot of prairies with wet areas in them. We have different vegetation. So it's really important for us to start tracking grazing effects in our own vegetation. Okay. So getting to the wetlands. The grazing started in 2012, and one thing we noticed soon after that is that there are some areas of wetlands out there that had attracted a lot of attention from cows. So you had this kind of effect. And this raised some concern among some ecologists and managers that, well, if these were high-quality wetland vegetation and they get churned up by cows, is that going to convert it to invasive species? So that's sort of one question. Okay. And then we also observed that there are areas of reed canary grass out in the site where cows were targeting the reed canary grass. And another question arose, which is, are there benefits to doing that? Does that enhance the growth of native species within an area that's otherwise covered with reed canary grass? Okay. So that led to, our two main questions for monitoring wetlands out there are related about intact prairie wet meadows versus reed canary grass dominated sites. Okay. So we set up a project to monitor wetlands using permanent transects, and you can see the wetlands pretty easily in the site using aerial imagery. Okay. Okay. And this slide shows how we selected wetlands. We wanted a representation of intact wetlands and a representation of the reed canary invaded wetlands. So we kind of categorized the different wetlands out there and then randomly selected from each of two groups. In the case of the native and partially native basins, it basically ended up selecting all that we could find, but randomly selecting the others. We had a total of 39 wetland basins that we've established permanent monitoring transects on. Okay? So we're monitoring them using the grassland monitoring team transect approach, 25-meter transects. The transects go through the middle of the wetland, and the orientation of the transects is randomized. Okay. And then on each transect, what we're doing is we're recording all the species that are present in 25 quadrats along the transect, recording their presence and absence, which I'll refer to as frequency, and their cover, which is the amount of space within each quadrat that each species occupies. In addition to that, we also assigned what are called plant group scores to each of 50 quadrats along the transect. Plant group score is based on the relative amount of native versus invasive species within each quadrat. So it ranges from in the hundreds for quadrats that are over 75% cover of natives to the 130s for quadrats that are over 75% cover of invasive species. And we also had there's also a 900 score in which if for quadrats that are more than 75% bare soil, they're ranked as 900 with a 900 plant score. And we found that this system was useful for identifying categories of different wetland basins or different transects, which is useful for thinking about some of the original questions we had about the wetlands out there. Okay? We also recorded visual obstruction reading, which is a measure of the density and height of vegetation in the site. And that is affected by a number of things, especially grazing, burning, and season's weather. Okay? And we've also included some information on the weather of the season out there, because we realize that this has an effect on what we're recording in the vegetation. In 2014, when we started monitoring the wetlands, it was a really wet year, and there was a lot of standing water in wetlands going into June, through June. Turns out there's a weather station right nearby in Milan where they recorded 14.09 inches of rain in May and June 2014. 2015 it was 8.8, but in 2016 it was only 2.27 inches. So near drought conditions. So there's quite a contrast in the weather conditions across the 3 years of this data set that I'm talking about. Okay. We did some analysis of our data with a generalized linear model. The response being change in frequency or cover of a species of interest from one year to the next. So if we're looking at reed canary grass, we're looking at its change from 2014 to 15 or from 2015 to 16. And we had some other factors in the analysis to get a sense of how that response variable is affected by things like presence in a burn unit, which is really a surrogate for burn and graze, because that's also when a transect is in a burn unit is the time when it has the most focused grazing as well as the burn. Spring precipitation as one of the factors, and also the starting state of the transect in 2014 as quantified by our plant group score. Okay? So this graph shows the visual obstruction reading, the average visual obstruction reading for each of the different burn units in each of the 3 years that we've analyzed so far. And what you'll see is the visual obstruction reading is the lowest for the management unit that's had the burn in that year, which is what we'd expect. And that's this interaction between the fire and grazing. The other thing to notice in this is that, in general, the vegetation was tallest in the unburned units in 2014, moderate in 2015, and lower in 2016. And that reflects the effect of the weather of the year, of the precipitation. It's strongly correlated with that change in precipitation from a wet year to a dry year. Okay. Well, were the cattle really using the burn unit? We had the opportunity in 2014 to put a GPS collar borrowed from the moose study up in the north, and had it on a lead cow out there in 2014. And it really did show that for much of the growing season, she did focus on the burn unit of that year. They also did a fair bit of wandering to the south end of the project area. They kind of like that south end. We're not quite sure why. So that kind of validates some of the theory behind patch burn grazing, is that cows really focus on that year's burn unit the most. Okay. We categorize the different transects in the project according to plant group score as a way of getting a sense, getting some insight into those questions about what's happening to the more invaded wetlands versus the native wetlands. So when we do that, we have a group that's had more than 15 quadrats per transect of bare soils, which I'll refer to as the bare soils group. A group where it's strongly dominated by reed canary grass, the reed canary wetlands. A group where there was kind of a mix of reed canary and native species, and then a group strongly dominated by natives for 75% cover of natives across the transect. And the main natives that we're talking about in these wetlands are blue joint grass, Calamagrostis canadensis, prairie cordgrass, and species of carex. Okay. This shows a distribution of those different wetland categories, in the project area, and mainly it's to illustrate the fact that they're not evenly distributed across the project area. The black dots are the ones with predominantly bare soils. They were concentrated in the burn unit of that year of 2014, or in a neighboring unit to the south. Okay. So I have a few bar graphs where I've organized the transects according to which category they may fall into. The bare soil category being, by definition, the ones that had a lot of bare soil in 2014. Invaded being reed canary dominated, mixed, and the native ones. Showing the relative amounts of whatever metric I'm showing in each of the 3 years. So this one is useful because it shows that the bare soils are really concentrated in the bare soil wetlands, well, obviously, but also that that occurrence of those bare soils was really limited to 2014. We didn't really see anything close to the amount of bare soils as a result of cattle activity in any of the other years in any of the other wetland categories. Okay. Some of those bare soil wetlands, the year after 2014, had a lot of kind of weedy species in them, such as tower mustard shown here and horseweed. But because we didn't start this monitoring before the grazing started, we have no sense of whether this represents a change from the way it was before grazing or whether they were always kind of these weedy wetland basins, okay? Now there's witchgrass, a common one, some of these, okay? But one of the interesting finds was that in a few of these wetlands that had a lot of bare soil in 2014, there is a lot of native annuals coming up in them. Next. Okay. Such as marsh yellowgrass, which is a native mustard annual. Okay. And a couple of rare species showed up in a couple of these wetlands as well. And these are plants that specialize in ephemeral wetland pools, places where there's water in the spring, but then the water evaporates and there are mud flats. So these are plants of naturally occurring wetland pools. So it indicates that at least some of the wetlands in our study have these naturally occurring bare soils. That's not only because of cattle activity. And for all I can tell, if cattle do go in there and create a lot of bare soils, it isn't a problem for these plants. I think it may very well enhance the habitat for these plants. And there's been a recently published study from California, from the ephemeral pools in California, that actually documents a positive effect of cattle activity on ephemeral wetland pools and ephemeral wetland species. Okay, next. Oh, and we only saw those plants in 2014. We never saw them in any of the subsequent years. So this one shows the frequency of reed canary grass in transects in these different categories. Reed canary grass didn't really change in frequency in the invaded, mixed, or native wetlands. It did have an increase in the bare soil wetlands. after the first year, and like I say, we don't know whether a lot of it was already there before we started monitoring. But we certainly haven't seen any increase of it in native wetlands. And in terms of our statistical model, no significant effects of the burn or precipitation on the frequency of reed canary grass, but some effect of the burn on cover of reed canary grass. That is, during burn years, reed canary grass was shorter, which is, again, that interaction between the burn and grazing effect. Okay? So early in 2014, this is from the south end of the project area, the cattle hadn't really discovered some of these reed canary grass wetlands that year, but then, okay, the next year and the year after that, when the burn was farther south in the management area, the cattle really focused on these reed canary dominated places. They discovered them early, they grazed them down, they kept them short throughout pretty much the season. So they've been definitely targeting these ever since. One positive benefit of this, of course, is that it is keeping a lot of reed canary from going to seed. Okay. So with the question of whether we're seeing more natives within the reed canary grass if it gets eaten down, one of the main natives we would expect to see some response, if there was one, would be species of carex, because that's one of probably the more common native that's within some of these reed canary dominated places. And on the bar graph on the right, it's the frequency of carex. That's the number of quadrats occupied by carex per transect. We have no real change in the different years. It's not, and no relationship with patch-burn-graze or bare soils. Whereas if you look at carex cover instead of frequency, cover is the amount of space occupied by the plant. We have significant declines in cover from 2014 to 2016 in all of these different categories for carex. And that strongly correlates with this change in precipitation between the 3 years. It really, if there was any positive benefit from mowing reed canary in the invaded basins, that would have been very much swamped by the effects of the change in precipitation. Okay. Kentucky bluegrass is increasing in our quadrats in all the different types except for the mixed, as it's illustrated on the right. It's also strongly correlated with or affected by precipitation, the change in precipitation, and increasing. And makes you wonder, well, perhaps in some of these wetlands, having a drier year creates more microhabitat for Kentucky bluegrass. One possibility. Oops. Could you go back, Jessica? On the left, we can look at the amount of increase of Kentucky bluegrass in burned versus not burned transects, and the amount of increase of Kentucky bluegrass in transects that were within burn units was lower than the amount of increase in transects that were not in burn units, even though the difference isn't significant. But it seems to say something about there being some effect of burning and grazing in maybe slowing down temporarily the increase of Kentucky bluegrass. Okay. Looking at native graminoids, no differences in their frequency across the years in these different categories of wetlands. No significant effects of burn or precipitation or bare soils. But next, there were a couple of wetlands where there was a relationship between some of the natives, the frequency of natives like blue joint grass and bare soils, but there just weren't enough of these to affect the whole data set. And this is an example of one of those wetlands. This is in Unit 5, this small circular wetland. Go to the next, okay. And it's in 2011, before grazing started, it was really dominated by blue joint grass all the way across. Okay. There's a shot of the blue joint. It's a low growing variant of Calamagrostis canadensis. Okay. And this wetland, this management unit was the burn unit in 2013, which was also a wet year. And so it had the combination of being in the burn unit and in a wet year, and it got attention from cows during 2013. In early 2014, you see the bare soils. Okay, next. And there, within those bare soils, you can see rhizomes of Calamagrostis there. Okay. Well, from 2014 and the next 3 years, there was relatively little attention from cattle in this wetland. And in the first, in 2014, you saw a flush of annuals such as yellow cress, which is the brown stuff in here, okay, and gradual increasing in the frequency of blue joint along the transect after that in subsequent years, and relatively little attention by cows in those years. So it's closing in, and but you can't. You can still see a little bit of an opening in it. Okay. All right. So to summarize, we're seeing cattle grazing on reed canary. We don't have any evidence of an increased expression of natives within it. I do agree with Don Schultz, who says, well, we can't really do anything worse to those wetlands by having cows in them. Next. We do have some that have weedy species in them that had bare soils in 2014. We don't know what they were like before. Next. And in some of the native ones, we don't have very strong evidence that we don't have any evidence of reed canary grass invading them. We do have a couple of examples of ones that did have bare soils, but because of the way patch-burn grazing works, the grazing pressure was rotated to other parts of the area. We didn't have the combination of burn unit and wet year in some of these after the beginning of our project. And so we have evidence of some recovery. So I think what that suggests is that these things can recover from a lot of bare soil that might happen in 1 year if they're given enough rest. So we would like to continue tracking these wetlands for several more years just to see if we can pick up another wet year and see how these cycles play out over several more years. So, okay. And then I'll just very briefly touch on some of the upland prairie monitoring that we're doing. This project was started before the grazing started. So we set up paired plots in the site in 2011, the year before grazing actually started. And what we did was, using a stratified random process, I located 25 pairs of plots, permanent plots, distributed among the different management units, okay? And each pair of plots, one member of the pair was randomly determined to be enclosed in an exclosure, which is a circular fence, so that we can sample ungrazed vegetation and compare it to the grazed plot, okay? Here's a shot of one of those exclosures, okay? That's a shot of the quadrats that we sample in each plot. We've sampled it 4 times now, including this past year. We're sampling it on a 3-year rotation, okay? And we've only just started looking at the data that we have, and when we looked at native species richness that we've recorded out there, we see no difference between the grazed and ungrazed over time from 2011 to 2017. No significant difference. We do see a slight increase in species richness in both sets of plots over time, but the one isn't increasing more than the other, okay? But one thing we have picked up is increasing amounts of smooth brome showing up in 5 more plots in 2017 than it was recorded at the start of the project in 2011. The exclosed, which are the ungrazed plots, started out having a few more quadrats per plot of smooth brome in them. It's purely a random effect. But there were significant increases in smooth brome in both the ungrazed and in the grazed plots over time. One isn't increasing at a greater rate than the other. But I think that this brome issue is going to be one of the main management issues for managers to deal with going forward. Okay. I've had a number of field assistants, including some staff of the Nature Conservancy who've helped us out every year, and they have been tremendous. We wouldn't have been able to do nearly as much work as without them. So very, very much appreciate all the help we've had. Okay. And in summary, I just want to point out that in grazing studies and in considering grazing, so much depends on how many animals you have in what kind of space for how long. And this is just one example, as the results may not apply very well to other grazing setups. So I'll leave it there, and I don't know if we have time for anything else. But
yeah, thanks, Fred. If anybody has questions, you can feel free to type into the chat. I guess that was kind of going to be my question, Fred, is where do we go from there as far as making recommendations for, you know, frequency and intensity of grazing? I'm just kind of thinking about the next step. You know, how do we try to decide what's enough and what's too much and what's not enough? I don't know if you have thoughts about that.
Well, I think that that argues for the need to monitor different approaches to grazing and coming up with some more generalizations about what works and what doesn't. But I think that the results are going to be different in different kinds of sites. I think that in general, dry, well-drained sites tend to be more resilient than sites that have wet soils that get more physical disturbance from cattle. So it's going to be difficult to make large generalizations.
Yeah. The drought is such a huge confound of all of this. So Phil's wondering, did cattle impact trees?
That's a good question. I wouldn't have any information on that. We have, there are some trees on the edge of the property of the south unit that they like to go and hang out with, and that may be one of the reasons why they tend to go down to that south end, is to seek shade. But I don't have any information on whether they've had impact on trees. We could look at our data. We have very few tree seedlings in our vegetation plot data.
Are there any other questions? I'm sure Fred would be happy to entertain emails too if you have a burning question after the webinar is over. I don't see any other questions coming in right now, but thank you so much, Fred. Thanks for putting up with all of the technical difficulties.
Thank you for putting up with all of this. I mean, it's like,
no problem.
Yes, you never know what's going to happen.
You never know.
Okay.
It's all right. We made it work. Well, next week we have Pauline Drobny and Amanda McCulpin from the U.S. Fish and Wildlife Service to talk to us about the Prairie Reconstruction Initiative, crowdsourcing data for faster learning to get good prairie from planted seed every time. So thanks for everybody else for bearing with us as we stumbled through those technical difficulties. Have a beautiful long weekend.